All right, picking up where we left off with the previous video, and our next question is number 20. So how many moles of oxygen are required to form 15 moles of calcium oxide? So trying to sort of dissect this question a little bit, we're being asked to go from moles of calcium oxide to moles of oxygen. That tells us that we are going to need a mole bridge. Okay, we need a ratio of calcium oxide to oxygen. And so looking at what we have in the equation, we have 1 mole of O2, 2 moles of calcium oxide. Okay, using the stoichiometric coefficient to tell us how many moles are in the equation. So now we're going to start with our given information, which is 15 moles of calcium oxide. And so I'm going to write a ratio that has calcium oxide on the bottom. So 2 moles of calcium oxide for every 1 mole of O2. Right, so our moles of calcium oxide will cancel out, leaving us with an answer that is in moles of O2. And we'll find that we have 7.50 moles of O2 are needed to make 15 moles of calcium oxide. So 7.5. It really should be 7.50 for sig figs purposes, but that's what we have. So question 21. So how many grams of calcium oxide can be formed from 2.5 moles of calcium? So sort of paying attention to what we're being asked here. We're being asked to go from moles of calcium to calcium oxide. In this case, we're going to grams. Okay, but the important thing there is that if I have to go from one thing in the equation to something else in the equation, I'm going to need a mole ratio. So in this case, I am dealing with moles of calcium. So I have 2 moles of calcium in the equation and 2 moles of calcium oxide in the equation. So that's going to be my ratio. It's a 2-to-2 or a 1-to-1 ratio. So in order to get to grams of calcium oxide in the end, I need the molar mass of calcium oxide. Okay, because that's my transition from moles to grams. So we have 1 times the calcium at 40.08 grams per mole. And I have 1 times the oxygen at 16 grams per mole. So my molar mass of calcium oxide is 56.08 grams per mole. Okay, so I'm starting with moles of calcium. Okay, if I'm already at moles, I don't have to do anything else. I can just go across the mole bridge. Okay, so I'm going to write my relationship to have moles of calcium on the bottom and moles of calcium oxide on the top. Okay, moles of calcium will cancel. Now that I'm at moles of calcium oxide, now I'm going to use the molar mass to get me to grams. Okay, I'm going to write my relationship to have moles on the bottom, grams on top. Okay, that way my moles of calcium oxide will cancel. And I know now that I have grams of calcium oxide as my answer, which should come out to be 140 grams of calcium oxide, which is our 4th answer on the list. So if 40 moles of boron react in this way, how many moles of F2 are consumed? Now I want to remind you about how these videos work. When we come up to these questions, it's best for you to pause the video, try to work out the problem yourself, and then come back and see how this goes. Okay, so taking a look at our problem. So we're being asked to go from moles of boron to moles of F2. Right, so I'm going to need a mole ratio to get from one thing in the equation to something else in the equation. So given what we have 2 moles of boron and 3 moles of F2. Right, so that's where my ratio is going to live. It's a 2 to 3 or a 3 to 2, depending on how I need it. So if we start with 40 moles of boron, I'm going to write a relationship that has boron on the bottom and fluorine on the top. Okay, so 40 times 3 halves, or 40 times 3 divided by 2, however you like to think about it, will give us 60 moles of fluorine. Okay, now I only had to do one step here because I'm just going from moles to moles. When I have to go to grams of something to moles of something, there's another step at the beginning before I get to the mole bridge. If I have to go from grams of one thing to grams of another thing, then I've got a step before and after the mole bridge. But the important thing is that in the middle is our mole ratio. That's how I get from one thing to the other through moles. So how many grams of boron are required to produce 815.3 grams of boron trifluoride? Okay, so here we are asked to go from boron to boron trifluoride. Right, so that means that somewhere in there I'm going to need a mole ratio. I'm going to need a mole bridge. Right, but if I'm starting at grams of boron, if I'm starting from grams of boron trifluoride, and I'm going to grams of boron, that means that I have to convert to moles first. So if I have, let me write this out instead of just using words. Grams of boron trifluoride to moles of boron trifluoride to moles of boron to grams of boron. Okay. This piece right in the middle here, that's my mole ratio. That's how I go from grams of one thing, or moles of one thing, to moles of another thing. But I'll have one step at the beginning before I get there, and one step at the end after I leave there. Okay, so our boron trifluoride, okay, hopefully you've already worked this out, but we'll go through it real quickly. So 1 times the boron at 10.81 grams per mole, and 3 times the fluorine, so 3 times 19 grams per mole, gives us a molar mass for boron trifluoride of 67.81 grams per mole. Okay, and we have, there's my molar mass of just boron, so we already have that bit. Right, so first I have to convert boron trifluoride to moles, then I use a mole ratio, then I convert the boron moles into grams of boron. And I'm going to do this all in one continuous equation. But I want to remind you all that you can still do this as one step at a time. You convert to moles, then convert moles of one to the other, then convert to grams, all in 3 completely separate steps. So our given information is 115.3 grams of boron trifluoride. I'm going to convert that to moles of boron trifluoride. So I use the molar mass. Okay, so my grams will cancel out. So if I stopped here, I would have moles of boron trifluoride. Okay, so now I want to use a mole ratio to convert to moles of boron. Boron trifluoride on the bottom so that it will cancel. So now if I stopped here, I would have moles of boron. But the question wants grams of boron. So my final step is to convert moles into grams using the molar mass of boron, putting moles on the bottom so they cancel out. Okay, so what I'm going to say in my calculator, if I'm going to do this all in one shot, I'll say 815.3 divided by 67.81 because it's on the bottom, times 1 because 2 over 2 equals 1, times 10.81 in our third step because it's on the top. Remember, we multiply on the top, we divide on the bottom, and we'll come out to 130.0 grams of boron. Okay, and the reason that I have 4 sig figs there is because I have 4 sig figs in my first part in my initial information. I divide by 4 sig figs. My mole ratio is counting numbers, so they don't factor into sig figs. And then I multiply by 4 sig figs, so my final answer should have 4 sig figs. Right, so a plan to run a reaction using 200 grams of tin, and we need to know how many grams of tin chloride will form. What steps are necessary for this calculation? So basically this is going through a map, okay? So if we are starting with grams of tin, and I need to go to grams of tin chloride, I know that in the middle I have a mole ratio where I'm going to go from moles of tin to moles of tin chloride. But on the outsides, I'm going to have conversions with grams. So my first step is to convert grams of tin to moles of tin. Right, so that looks like, could be this one, could be this one, could be this one. Okay, once I have moles of tin, now I need to get moles of tin chloride because the relationships are through moles. Okay, so that's going to count out answer number 2. We're also going from moles of tin to moles of tin chloride, and our answer 4 goes from moles of tin to moles of HCl. We don't care about the HCl in this problem, so that's going to cancel out answer number 4. So we've covered grams of tin to moles of tin to moles of tin chloride, and then our final step is to convert moles of tin chloride to grams of tin chloride. Okay, I'm going to go ahead and stop this video right here, and we'll pick it up with question 25 on our next video.